Today we're going to build a chat with PDF files Langchain code file, and we're going to test it on 2022 Nvidia Corporation Annual Review, also the GPT-4 Technical Report paper, and along with the Attention is All You Need, which was the seminal paper which was published 2017, which gave birth to Transformers with Attention. Let's start with a quick demo. I'm just going to run this app, and then we're going to review the code. All these code files along with the PDFs are going to be available for my Patreon supporters. The link will be in the description. And we run this. We get an available documents list, which are all the PDF files we have under a folder named Documents. Here we have a list and we have numbering. It's asking us to enter the index of the document. Let's start with Attention is All You Need. Once we select, then it asks us, do we want to index all the pages or a custom range? Because we can either index the entire document or for a custom range. The reason why the custom range is important, I thought, was because maybe you just want to test some stuff with really large documents, because the Nvidia report is 200 pages and GPT-4 paper is about 100 pages. So this is why I thought of this. In this case, let's just go with all, because Attention is All You Need is only 15 pages. After we create with persistence, we create the DB index, so we don't have to do this again. Do you want to generate a summary? It's asking us yes or no. If you say yes, it's going to generate a summary. If no, then we can start chatting with the document. But let's say yes. Well, this part might take a while. We are using ChatGPT 3.5 Turbo, but with Langchain, it's actually not making parallel calls for some reason. But anyway, the summarization, I've set it up with the MIP reduce chain type. I also want to mention that I have used the rich library to actually make this beautiful colorings. You can actually really work it and make it look like exactly as how you want it. Anyway, here's the summary. The paper introduces a transformer and it goes on to explain. This took about 30 seconds. Let's ask it a question. What are transformers and attention? Now it's going to find the relevant chunks from that, and then it's going to answer our question. Transformers are a type of neural network. It explains attention mechanisms are a key component of transformer models. So this is lovely. Let's try the Nvidia annual report. Let's run this again. This time we'll select index 2 for the Nvidia report. We want to select the custom range to index. We're going to select our first page as 0, the last page is 10. These don't exactly relate to the pages, but they do somehow, somewhat. Anyway, while it's doing the indexing from page 0 to 10, I just want to say that on page 3, the Genomica said that Nvidia provides the core technology reshaping industry. The reason why pages don't correspond exactly with the pages is because some pages are blank, actually. Anyway, now it's asking us if we want to generate a summary. We say no, and now we can ask it questions. We're going to ask, what did the Genomica say about Nvidia? And we get the answer that Nvidia provides the core technology reshaping industry and society. If we go back to the PDF, that's exactly what it said. And this is only from indexing the first 10 pages or the first 10 elements in the list. Now I'm going to run this again, and this time select the GPT-4 paper. I'm going to select all of the document and get it embedded, all of it. And I just want to mention that when we change from custom to all or anything like that, we automatically detect it by a hashing function, and we rewrite our index automatically. And whenever our index doesn't change, we load from that index, and when our index changes, we create a new index. We'll demo that too. Anyway, do we want to generate a summary? No, because that will take a while. We just want to ask it some questions, but from the very bottom of the document. For example, let's say towards the end of the document, there's this content classifier development. Let's ask it about the moderation API endpoint. Let's just ask what are moderation endpoints. So I ran this 3 times. When I asked what are moderation endpoints, it said it doesn't have enough context. When I said what are moderation API endpoints, it still didn't have enough context. But when I asked what is content classifier development, then it actually gave the correct answer. I just want to mention that, yes, there is the content classifier development, but I was just trying to pick the moderation API endpoint from the middle of it. This is to illustrate the limitations of the simulator search model. Maybe I'll make another video trying to improve on this. But just as a quick demo, the kind of questions you ask really improves the performance. So you have to really think about the kind of questions you're asking to the document. Lastly, I just want to demo the fact that this system that I set up, this code automatically keeps tracks of the persistent directory with ChromaDB. And if that situation changes, rewrites over the index. And if it doesn't, it loads from the index. For example, we're still going to choose GPT-4 again. And if you remember, we had loaded all of it. And if we again select all, this time it's loading from the index because we haven't changed anything. However, if we run this again, and I select the GPT-4 again and determine a custom range, for example, from 0th index to, let's say, 20th index, then we're going to see that it's actually creating a new index with this range. And we can create a summary of that range as well. This option might be useful because you can actually select smaller ranges and get summarizations for those ranges. And you can actually question smaller chunks out of the document as well by using this custom range page indexing. Okay, we got a summary of that 0 to 20th index. OpenAI has developed GPT-4 large-scale multimodal language model and goes on to explain. Now let's review the code. Before we start reviewing the code, I just want to mention that all of these files will be available for my Patreon supporters. And I'm also starting to do AI workshops and live QA sessions throughout the month, regularly occurring for Patreon supporters as well. Just take a look at my Patreon page, see if this is something you'd be interested in. Now, I just want to mention I have this requirement.txt file. I want to mention that you want to pip install all these OpenAI Langchain PyPDF, which Langchain uses now to load PDF files, which I have compared with unstructured, and it actually is very similar. Unstructured is a little bit better, but much slower. So that's why I use PyPDF, and it's unstructured also is very difficult to install. I made a video about that too. You can find it in my channel. Pip install ChromaDB and pip install Rich, and also upgrade these as well. Pip in whatever library and then -upgrade. You can do this by saying pip install -r requirements text -upgrade, or you can also do it pip install OpenAI -upgrade, pip install Langchain -upgrade, so on and so forth. I also was having a special error for some special token usage, which the tick token was raising when trying to create the vector store index. That's why I had to actually modify the original OpenAI embeddings class from Langchain. So modify.py actually has the modified version. And the part that I changed is this part, encoding encode, disallowed special. So this actually fixed the error. If you run into the disallowed special tokens, then this took me quite a while to figure out. But anyway, so I have this file which I'll be providing. I do want to say that this is just the OpenAI embeddings, which you normally would import from Langchain. But you find this file and you do the modification to the _get safe embeddings and change essentially the token encode text disallowed special equals disallowed special. I believe this is all you have to do. And instead of changing the original file in the Langchain repository package, we just copied and pasted the entire class in the modify.py file. And in our main file, we are actually importing the OpenAI embeddings from this modified file. Okay, this is just a less intrusive way of doing it. Anyway, let's just continue with the code. We are importing this hashlib for determining our index. We're going to talk about this here in a second. We are doing the glob to find all the files from our documents right here, all the PDF files that we have. Langchain.document, we are loading the PyPDF loader. We're going to be using that for PDF. We are using Chat OpenAI. We are not using OpenAI. I'll just comment this out. Anyway, we are importing document load summarize chain for summarization. We are importing OpenAI embeddings, remember, from our modified.py file. Normally, we would import this from Langchain. We are using ChromaDB, and we are using the new retrieval QA. And we are importing from Rich the print, rich.console, the console and the table. This is for some beautification purposes, as you've seen, for printing into the terminal. This is just my warning so that you pip install all the requirements with the dash upgrade option. You do also have to define your OpenAI API key. I have defined it in my user environment variables as OpenAI API key. Like this is probably the best way and the most secretive way. Or you can define it in your code. This is not recommended. Or you can define it in a .env file. But anyway, this first option is the best in my opinion. And we are creating a console by defining the console to be the console which we imported from Rich. You can read about the Rich library. And then we are creating our class, chat with PDFs and summarize. We are initializing our model and our temperature. You can also initialize your other, for example, max token count and stuff like that here. I am defining two different chat OpenAI LLMs, one for summarize, one for chat, because you might want to use, for example, just the OpenAI Text DaVinci 003 model for summarize. In that case, you can change this. I've actually used it to summarize the entire Nvidia 2022 annual report, and it cost me $5.30. It was much faster than GPT 3.5 Turbo because of the fact that the load summarize chain works faster with it because it applies some parallelization, and it's not available with the chat currently with Langchain. Anyway, we are initializing our loader, pages, docs, DB index, embeddings to our modified embeddings so we can avoid that error as we've talked about earlier. Our persist directory is DB index and doc hash. This is going to determine if our indexing is changing. As we are asking the user if they want to index a part of the document or all of the document. So this hash is going to allow us to keep track of it. Then we are loading a PDF document and split it into pages. We are defining a method. It takes a file path and page range. This is related to the hash. Our loader is PyPDF loader from Langchain, and the splitter is that self.loader.load and split. This is why this is super easy. This just gets it done. Both loads the document and splits it page by page, but it doesn't do the pages perfectly, but gets pretty close. Then we ask we want to ask the user for a page range. And when we are determining the document and the page content, T for page content, for T in self.pages, we are doing list comprehension here. So if the user had picked a page range, which we initialized to the none, then we select those range, else we select the entirety of the document. Then we calculate a hash for that. So this is interesting actually, you might want to read about it, but it creates a hash based on the documents that have been created. Really cool. So this way actually if the index changes, then this hash changes and we can do some comparisons. Then we check if the persist directory exists. If not, we create it. db.index, right? And we also, to be able to compare, we check if in the persist directory doc.hash text exists. If we just take a look at it, it's just a interesting number, which is the hash number. If not, we create it and we store the hash right here, this. And we check if the new hash, which we are determining here, is the same as the old hash, then we load from the index, right? So we use this line, db self.db index is going to equal to this syntax, because this is the way that you load with ChromaDB. Otherwise, we're going to get new docs and a new hash, and we're going to create a new index using this syntax for ChromaDB. So loading with ChromaDB and saving is a bit different. Pay attention. We are using the embeddings here versus when we're loading, we're not. Yeah. Then we are writing the new hash file into the doc_hash.txt. So if doc.hash exists, which means that we already have the db_index folder have created, right? So we check for that and we compare the hash. So this logic handles if our current indexing is the same as the one from before. So we can just load it. But if the hash doesn't exist, then we again have to create the docs, is the new docs and the new hash. And we again have to create a chroma index, because that means that there was no hash. That means we haven't done the loading of the vector store index. So this else handles that. I'll just scroll through it like this. Then we define a summarize method here. We're using the map reduce chain type. You can try it with refine or map re-rank. I like this one the best personally. We check for self.docs. If not, we have no documents loaded. This is just kind of like an error check. Then we load our load summarize chain with self.llm summarize, which we have defined at the top right here, remember? And our chain type equals to the chain type, which we are getting from our method, right? And then we return the chain.run self.docs. So this is our summarize method. I also created a method for printing test pages just to see if you're loading the documents right or if you want to change your splitting. So you can take a look at this. If there are no pages, then no document is loaded. This is for error checking, right? Kind of. And for index and page indices, you can actually print those if you like. I'm not using this in this code, but I've left it here if you want to try it out. And then we have our ask a question and get an answer from the model. So this is the chat method, right? Ask question. It takes in a self because we are still in the class. This is a method. And it takes in a query. If not self.db index, again, we're saying no document index. Please load a document first using load document method, right? And then we initialize a retrieval QA object. We just say our QA is equal to the retrieval QA dot from chain type. And our LM is self.llm chat, which we have defined up here, right at this, in the beginning of our class. And our chain type is stuff because we just want to stuff as much information to it as possible, which we are retrieving from our vector store. And our retriever, we also have to define a retriever. And I'll just pull this back. Is self.db index as retriever. So this is just the syntax of how you define a retriever. So this is going to take care of our similarity search, I believe. And then the retrieval QA will actually take that. So we are using a retrieval QA chain with a retriever set to our db underscore index. Then we simply run that QA because we are assigning that retrieval QA to QA. We run that with a query and we get a response and we return that response. And our main script starts here. If name is main, then we assign our chat to be our class object. Then our document list, we use the glob, which we have imported to get all the PDF files from our documents. This current implementation uses it one at a time, but maybe I'll make some improvements along with maybe Streamlit UI in the future. Anyway, so we are preparing a rich table for displaying available PDF documents. The docs table is the table which we have imported up here from rich, just like this. And we are assigning to docs table. We're saying the table title is available documents, show headers true, header style, bold, magenta. You can actually apply all kinds of styling using rich. Docs.table add column, which is going to be index, justify right, style dim. Docs.table add column, document, justify right, styling is bright yellow. These are all the, let me actually run this so you can see it real quick. So these are the stylings that actually establishes this right here. As you see, available documents, and then bold magenta, right? The header styles, which is the index in the document. Anyway. And then we are, for index and document, enumerate in the document list, we are actually getting it and getting the row, string index in the document. And now we're printing console print docs underscore table, which we have created right here, which gives us this in the terminal. Let me ask the user to get an input, enter the index of the document. Right here, this is what's happening. So we can just select, for example, 0, and then we run this. Right after that, we come to this next line, page range option. So it's asking select pages to index all pages or custom range. Okay. And then we do a check here. If page range option dot lower, so it doesn't have to be a capital letter C, then we will ask for a start page. Let's just test this real quick. Let's put it in a C. See, if it is C, then it's asking for a start page from 0 to index, whatever the final index is. Really don't know what the final index in the list is, but it's quite high. I guess that I could have implemented something to know that, but we can start anywhere. Like we can start from the 10th to the, let's say, 15th, and see, it's creating the new index. So we have created it. Then next we come to, we have done the load document then, given the page range. Remember, we have defined our load document up here somewhere. our method, which we have talked about. Then we get the console.rule document loaded. This gives us this nice little indicator. Then we ask the user again, do you want to generate a summary or no? Let's just say no. Then we actually skip this. Otherwise, we would have done chat.summarize and we would have printed the summary in a bold style. But otherwise, we just go into a while loop and then we query the console input query, which is this right here. And then our answer is going to be chat.askQuestionQuery. AskQuestion was another method that we defined earlier, remember? And then console.print answer is our answer. So we can just talk to this document just like this. What is attention? Attention is a mechanism used in machine learning and natural language processing that allows the model to focus on specific parts of the input when making predictions. Anyway, I really enjoy this. I think this can use some improvement. I'll actually zoom out and scroll it again. Like I said, all of these files are going to be available to Patreon supporters. And take a look. Maybe you'll be interested in the workshops as well. I'm looking forward to doing more of those. Anyway, I hope you found this useful. Take care and see you in the next video.